Now we are going to study question from October 2014 exam, question 2. Everyone give the heading, October 2014 exam, question 2. Now try to see the scenario here, what the question want to say. A helicopter is see the point here. I am going to read the question. This question is very interesting and it is little bit different from the last previous two questions we solved. A helicopter is what? A helicopter is 3000 nautical miles due south of a ship. Okay, see, I am going to draw the drawing here also. So, try to see the scenario here, everyone. Don't draw anything, don't write anything. Just observe the things on the screen properly, guys. Okay, don't do any other task. Okay, I am going to draw first of all space diagram here in this scenario. In this scenario, first thing I am going to draw, which diagram I am going to draw? I am going to draw space diagram. Okay, so this is what a north direction, this is a south direction, west direction and east direction. Okay, now a helicopter is what? 300 nautical miles due south of a ship. Okay, due south. Okay, suppose this is what a initial position of a ship. Okay, this center, see this one, I have denoted by this black. See this one, everyone, it is okay. So this will be what? This position will be what, everyone? Initial, what, guys? Initial position of what? Initial position of ship. Okay, this is what, guys? This is what? Initial position of ship. Okay, so this is what? Initial position of ship. With respect to ship, helicopter as where is a helicopter? 300 nautical miles due south. Okay, means if this is a ship position, with respect to ship position, helicopter is where, what, guys? In due south position. At how much distance? So this due south, and how much distance? Everyone, how much is the distance? So this distance is how much they have mentioned in the question? 300 nautical miles. So this distance will be what, everyone? So this distance will be what? 300 nautical miles. NM means nautical miles, guys, for us. Okay, so this is what? And this drawing indicating what? What is this drawing? What is the name of this drawing? We will give space diagram. Okay, what is the name of this drawing? We will give the space diagram. Okay, now try to see the scenario here. So this is the position of ship. With respect to ship, helicopter is in due south direction. So it is in south direction. And how much distance? 300 nautical miles away. Okay, now I am going to read the question further. Try to see the scenario. Very simple question, guys, not that much difficult. Absolute speed of the ship. Guys, I told you two types of speed. One is a relative speed and another one is absolute. Absolute means what? With respect to earth. Okay, so absolute speed of the ship is what? What is the absolute speed of ship? V ship is how much? Everyone, how much V ship? Please go through your numerical. So V ship is how much? 18 knots. So V ship is equal to 18 knots. In which direction ship is moving? In which direction ship is moving? 30 degrees south of east. 30 degree, what, guys? Everyone, in which direction ship is moving? 30 degree what? South of what, everyone? 30 degree south of east. So this is the direction of ship. Then speed of the helicopter, what? V heli, we will say. Speed of the helicopter, that is what? A V heli. V heli is how much? 120 knots. Try to see the point here. Okay. Now try to see the A part, guys, with me. So in A part, what they are asking us? The course taken by the helicopter to meet the ship as quickly as possible. What is the meaning of word, guys, course? I think in friction chapter, guys, in friction chapter, there was one question is there. Question was there. We have to find out course. Okay. So course means what? The course to be taken by the heli. Course means what? Course taken by the helicopter to meet the ship as quickly as possible. So in A part, what they are asking us, course taken by the helicopter. Okay, what is our target in A part, guys? We have to find out course taken by the what? Course taken by the helicopter. For what purpose? To meet the ship. What, everyone? To meet the ship as quickly as possible. And it means, what is the meaning of course, guys? What is the meaning of word course? What is the meaning of this course word? What is the meaning of word course? Everyone try to see the scenario. Meaning of course means what, guys? Meaning of word course means what? Direction. So here we have to find out direction of helicopter. What we have to find out in this task? In this A part, what we have to find out, everyone? We have to find out direction of helicopter. Listen my words carefully, yeah, guys. Very, very interesting task. Okay. Now this is what, guys? This is what a space diagram. Now this is, see, in last two questions, guys, the two ships, is they are meeting? Guys, are that two ships are meeting? In the previous two questions, guys, in the previous two questions, in first question, first ship, second ship. Okay, they are coming close, but they are not meeting to each other. Okay, they are not meeting to each other. But in this scenario, we have one ship and another one is helicopter. So here helicopter is going to meet the ship. Guys, listen my words carefully. Helicopter is going to meet the ship. Listen words carefully. Yeah? This point is very, very important to us here. So here helicopter is going to meet the ship. So when observer on the ship, suppose there is an observer on the ship. When observer on the ship is observing the helicopter. So this is what is meant by this one, guys? What is meant by this one? This is what, everyone? Initial position of what, guys? Initial position of what? Helicopter. Okay, good. Initial position of what? Helicopter. Okay. Now, what is happening here? Helicopter is going to meet the ship. So, now when observer on the ship is going to observe the heli, what it feels, guys? Suppose if helicopter wants to meet the ship as quickly as possible. Suppose we are going to make the ship as a relatively stationary. Suppose what we are going to do? We are going to do ship as a relatively stationary. You got the meaning of word relatively stationary? Meaning of relatively stationary means what? Observer is on the ship. Meaning of relatively stationary means what? What is the meaning of word relatively stationary? Observer is on the ship. Okay, guys, try to see the scenario. When observer see, so suppose now we are going to make the ship a stationary. Suppose ship is stationary, then how? Suppose helicopter want to meet the ship as quickly as possible. When it will be possible, guys? Suppose ship is stationary at this position and helicopter is at this position. So which path should be taken by the helicopter to meet the ship as quickly as possible? The word is what? As quickly as possible, guys. Huh? What is the word? As quickly as possible. See the word here. So if the helicopter want to meet the ship as quickly as possible, then how should be the path, guys? How should be the path? How should be the path, everyone? How should be the path? It must be, see, if helicopter want to meet the ship as quickly as possible, suppose ship is stationary here, relatively stationary, just we are assuming. Suppose ship is relatively stationary and helicopter is here. So which path should be taken by the helicopter to meet the ship at this position? It should be straight path, guys. See, which path should be taken by the helicopter? It should be straight path. Try to see the scenario here. So we can say, so this straight line indicate what? This straight line indicate what, right? So this is what? A path of helicopter. Now this red line indicate what? What this red line indicate? Everyone, what this red line indicate? Path of the helicopter to meet the ship as quickly as possible. And here ship is what? Relatively stationary. When ship is relatively stationary means what, guys? What is the meaning of this word? Meaning of this word means what? This path is relative path. Guys, see, if you are making the ship relatively stationary, means observer is on the ship. So when observer is on the ship and helicopter is following this path. So this path means what, guys? What is the meaning of this path? Relative path of what, everyone? Relative path of helicopter with respect to what, everyone? With respect to ship. Okay guys, are you getting my point? Try to see the scenario. And why we are taking this path? Why helicopter is taking this path, guys? Why helicopter is taking this path? Because helicopter want to meet the ship as quickly as possible, because there may be any emergency, medical emergency or something other emergency is on the ship. Okay guys, are you getting my point? Suppose there is some emergency due to that, okay, some emergency, so helicopter want to meet the ship as quickly as possible. Okay guys, are you getting my point? Try to see the scenario. Very important discussion is here. So now how to deal with such type of scenario? So now observe this drawing. See, earlier in previous two questions, guys, what we have done? First of all, we calculated direction of relative velocity. First of all, we find out, we got the direction of relative velocity, and from the direction of relative velocity, we got the direction of relative path. Means, whatever the direction of relative velocity, the same direction is of the relative path. So, reverse can be also true. Means, whatever the direction of relative path, guys, see, in last two questions, whatever the direction of relative velocity, see the direction of relative velocity must be same as what, guys? Must be same as what? Direction of what, everyone? Direction of what? Relative path. Okay. Or we can say reverse also true, guys. Whatever the direction of relative path, same will be the direction of relative velocity. So guys, try to see the scenario here. So guys, are you getting my point? Try to see the scenario. So at the end, what is the concluding statement we can say? Direction of relative velocity of helicopter with respect to ship is in which direction, guys? Observe the drawing. In which direction? Where? So at the end, for meeting the ship, guys, see the statement. For meeting the ship as quickly as possible. For meeting the ship, what, guys? For meeting the ship as quickly as possible. So here we got direction of relative path. Okay, from this drawing, what we got, guys? We got the direction of relative path. Relative path in which direction, everyone? Relative path is going in which direction, everyone? Relative path is going in which direction, guys? In which direction? In due north. So for meeting the ship, so from this, whatever the direction of relative path, same must be direction of relative velocity, and this is the relative path of what, guys? This is the relative path of helicopter with respect to ship, because here, why with respect to ship? Because we made the ship relatively stationary here. Okay, means observer is on the ship and that observer is observing the helicopter. So he feels that, the observer on the ship feels that helicopter is following this path. Okay, everyone getting my point? Try to understand the scenario. So what we can say? For meeting the ship as quickly as possible, relative velocity of heli. Guys, see, relative velocity of what? Relative velocity of helicopter with respect to what? With respect to, meaning of this symbol means what? WRT, this is standard symbol, guys. With respect to what? With respect to ship must be in which direction, guys? So whatever the direction of relative path, same must be direction of relative velocity. So relative velocity helicopter with respect to ship must be in which direction? Must be in north direction. Okay, everyone getting my point? Try to see the scenario here. Anyone have any doubt in this discussion, guys? This point is understanding this point is very important to us. Anyone have any doubt in this point, guys? Anyone have any doubt in this point? This point is very important. See, in last two questions, what we concluded, guys? In last two questions, from relative velocity, we got the direction of relative path. But in this question, guys, scenario is what? In this question, scenario is what? In this question, scenario is what, guys? From relative path, we got what? We got the direction of relative velocity. Okay, so here we got, first of all, we got the direction of relative path, and from relative path we got the direction of relative velocity. Okay, everyone getting my point? Try to understand the scenario here. Okay, anyone have any doubt here, guys? So here now what we got, guys? What we got? We got the direction of relative velocity. Guys, see See the scenario. We got the direction of relative velocity. This is not an answer. What they are asking us, direction of absolute velocity of helicopter, huh, guys? What they are asking us in the question? In the question, they are asking us direction of absolute velocity of the helicopter. Try to see the point here, everyone. Okay, guys, are you getting my point? So now try to see the scenario here. What the question want to say? So now here, so first of all, we have drawn this space diagram. From this space diagram, we got the direction of relative velocity of helicopter with respect to ship. Now, from this space diagram, we are going to draw the velocity vector diagram. Okay. So in this question, story is inverse as compared to last two questions. Guys, but the story is not that much difficult. Okay. So as usual, what we are going to draw? We are going to draw what? Everyone, try to observe the scenario here. What we are going to draw? Everyone, try to see the point here. Okay, very, very important discussion. So, first of all, see the point here, everyone. I am going to draw the reference line. This is what a north direction. This is what a south direction. This is west. And this is what a east direction. Okay, observe the scenario here. What is the direction of, guys, what is the direction of ship? South of east. Means it is in between south and east, and 30 degree with respect to what, guys? With respect to east or with respect to south? 30 degree with respect to east because of east. Okay, listen this point. Okay, so now here try to see the scenario here. So we got the what we got, everyone? So V ship. So this is what a velocity of ship. Okay, and this ship is making with respect to east 30 degree. Okay, this is visible to everyone. Observe the drawing here. This drawing is visible to everyone. Okay, anyone have any doubt in this drawing? Okay, good. Now the next point is what, guys? What is the next point here? Now here, what we have to find out, we don't know the direction of helicopter. We don't know anything about the helicopter, guys. But what we know, guys? Try to see the scenario. We know the direction of relative velocity of the helicopter. And guys, here relative velocity of helicopter with respect to what? With respect to what, guys? With respect to ship. And it is in which direction? It is in which direction, guys? Direction of relative velocity. It is in north direction. Okay. It is in what? It is in north direction. So in north direction, try to see the point here. So, and with respect to what, guys? With respect to ship. Guys, in the theory, I explained you, and in the last numericals also, I explained you with respect to what? Whatever the respect to. From that point must be the starting point of that arrow of the relative velocity. So with respect to here, ship. So with respect to ship, if with respect to ship of relative velocity of helicopter with respect to ship, so that relative velocity must be start from what? Where ship ended, from that point, guys. We will show this arrow. Everyone, try to see the scenario here. So this will be what, everyone? So this will indicate what, guys? This will indicate what? This will indicate relative velocity of what? Relative velocity of heli with respect to what? With respect to ship. Okay, guys, are you getting my point? Try to see the scenario here. Okay, and this is what our east direction. Guys, any doubt in this drawing? Any doubt in this line? Guys, observe this one. Anyone have any doubt in this one? Please observe this one. Because here we know. Oh, see, from the center, guys, see. If you remember our last two velocities diagram, from centers, which velocity we used to represent? From the center, which velocities we used? Absolute velocity. Here, what is this? This one is what? Okay, so see, your doubt is correct. What you feel is that it must be from center. That is, you feel like that, na? But which center, which velocities we used to represent? Which center we used to represent? Which velocities absolute velocities. Okay. Now, so, and guys, I told you, relative velocity with respect to ship must be start from where, guys? relative velocity of helicopter with respect to ship. So with respect to what? With respect to ship. So if it is with respect to ship, then it must be start from where, guys? It must be start from the where ship ended. From that point it must be start, guys. Remember this point. If you observe our last two questions, in the last two questions also we followed the same thing. Absolute velocity starts from the center. Okay. Now anyone have any doubt, guys? Anyone have any doubt in this drawing, guys? Understanding this drawing is very, very important. See, this is very, very easy question, guys. Only understanding you require. Okay. Anyone have any doubt here? Now, guys, so we represented two velocities. Now, guys, you may feel that, okay, now you may feel that, sir, why you are not ended here? You may feel that like that also. Sir, instead of this one, you may feel, okay, you may feel that what you will feel, guys? Why I have not ended here? Why I have not ended here? Instead of that, yes, it is very, very high, guys. Velocity, speed of the helicopter. So relative velocity will also be approximately high itself. So that's why. So V shape is what? Very small, 18 knots only. But VL is how much? 120 knots, guys. I try to see the speed of helicopter. So this is what our relative velocity of what? Heli with respect to what, guys? With respect to ship. Okay. Now try to see the scenario here. Very, very important discussion. Now what we discuss, guys? Absolute velocities start from where? Absolute velocity starts from where? Just few minutes before we also discuss that one. So now which velocity is remaining here? Guys, which velocities? There must be three velocities. Two absolute velocity and one relative velocity. Which absolute velocity is remaining here? Which absolute velocity? Helicopter. So this closing side must be helicopter. Guys, see this closing side. Whatever this closing side, guys, see. This closing side, which pen I will use? Okay. Suppose, guys, this green pen, is it visible to you, guys? Okay. So writing by green pen, it is difficult, now. Okay, 1 minute. Suppose I will use, which color pen I will use? Suppose I will use blue pen. Okay. So try to see the scenario here. Okay. So this is what? This closing side will be what? So this closing side will be what, everyone? What will be this closing side? V heli. What will be this closing side, guys? This closing side is what? V heli. Okay, everyone got this point. Try to see the scenario here. Okay. Anyone? And see. Guys, see. Whenever this is relative velocity of what? Relative velocity of heli. So relative velocity of heli must be end on this one. So direction of relative velocity and direction of relative velocity of heli means arrow of relative velocity of heli and velocity of heli must be same point. Guys, see. If you remember our last discussion, go to your theory. Means suppose this is what a ship A, this is what a ship B. And if you want relative velocity of A with respect to B, if it is with respect to B, then it starts from B. Okay, so closing side starts from B. And so here, this is what a relative velocity of A. Relative velocity of A with respect to what? Guys, B. So closing side is relative velocity. With respect to what? With respect to B. So it starts from B. And where it ends, guys, it is of A. So where it should be end at A. Okay, guys, are you getting my point? So we got, how we got this VLE? So now we are nearer to our answer of A part. Very simple discussion, guys. Anyone have any doubt in this discussion, guys? Anyone have any doubt in this discussion? Observe the things here. Okay, things are visible. This VLE is visible to everyone. Okay, good. Now we need what? Direction, guys. Okay, for direction, what we are going to do? We are going to assume this angle as a theta. Okay, what we are going to do? We are going to assume this angle as a, what we will assume? This angle as what, guys? We are going to assume this angle as a theta. Okay, if this angle as a theta, then by default, This is a vertical line, this is also vertical line. Then by default this angle will also become a theta. Okay, anyone have any doubt in this direction? So if you got the value of theta, then ultimately this theta means what, guys? If you got the value of theta, then ultimately this theta means what? Our direction of what? Direction of absolute velocity of helicopter. So this is what, everyone. So this is what, this theta means what? So means direction of helicopter, course taken by the helicopter to meet the ship as quickly as possible will be what, guys? Theta, east of north. So whatever the value of theta we will get. So from that, okay, everyone getting my point? Try to see the scenario. Now next point here. Try to see the scenario. If this is 90 degree, guys, this is 90 degree. Anyone have any doubt in this one? This line 90 degree. So now my question is for all of you guys, what will be this angle? What will be this angle, guys? If this is 90 degree, what will be this angle? Everyone, I have given you hint also. 60 degree, guys. See, sum of three angles of triangle. This one, and this one. So they will form a triangle here. They will form one triangle. So sum of this one, and this one is what? 180 degree. Out of this angle is what? 90 degree. So we remove that 90 degree. So remaining two sum will be what? 90 degree. Okay, guys. So 30 and this is what? So remaining this one. These two sums must be what? 90 degree. So if it is 30, then this will be what? 90 minus 30. So it will become what, everyone? 60 degree. Anyone have a doubt in this 60 degree, guys? Observe the things here. Okay, good. Okay. So now, guys, what is our target here? What we have to find out? We have to find out this theta. How to get the theta, everyone? How to get the value of theta? Try to see the scenario. We are going to use our favorite thing, sine rule. Okay. So by sine rule, very simple discussion, guys. By sine rule, theta. Theta's opposite is what? V-ship. So V-ship. There is a name of one company also, na? V-ship, guys. Okay. So V-ship divided by what? V-ship divided by what? Sine theta. V-ship divided by sine theta. And we know this angle 60 degree. So V heli divided by what? Guys, anyone have any doubt in this discussion? This expression I have written sine rule. See, V-ship opposite theta. So V-ship divided by sine theta. V heli divided by what? Sine 60. Okay. So what is our target? We have to find out value of theta. So sine theta will be equal to what, everyone? Sine theta will be equal to what? V-ship. Try to observe the thing into sine 60. Very simple discussion, guys. Divided by what? V heli. So sine theta is equal to, what is the value of V-ship, everyone? V-ship is what? 18 knots. 18 multiplied by, check it out, guys. If any 18 multiplied by what? Sine 60. And then what? Divided by what? V heli. V heli is how much? 120 knots. Guys, very higher value. So sine theta is equal to what, everyone? What will be the value of sine theta, everyone? Please calculate the value of sine theta. 18 multiplied by what? 18 multiplied by sine 60 divided by what? 120. How much? 0.1299. So what will be the value of theta, guys? Sine inverse of 0.1299. So theta will be, so please everyone, 0.1299, 7.4638 degree. Okay, so we got the value of theta. Everyone getting my point? So at the end, what is our final concluding statement? What will be the final concluding statement, guys? Okay, so concluding statement will be what? Course taken by the helicopter. What, everyone? Course taken by the what, guys? Course taken by the helicopter to meet the ship. Course taken by the helicopter. What? For what purpose, guys? Course taken by the helicopter to meet the ship. To meet the ship as what, everyone? as quickly as possible. So what will be the course, everyone? Is what? 7.4638 degree. What? 7.4638 degree what? East of north. See here. It is in between what? North of, no. How it is north of east? Theta with respect to what? Theta with respect to what here? Observe here. East of north, guys. Okay, anyone have any doubt in this discussion? Please guys, observe the things. So, east of north. Yes, we can say that one also. Okay, no problem. You can say like, you can say 90 minus theta. If whatever the value of 90 minus theta, then that will be what you can say? North of east then. Okay, 90 minus theta means north of east. Okay, theta means east of north. Okay guys, are you getting my point? Good. So this is what our But see, why we have drawn this phase diagram? What is the purpose? See, your doubt is what? Can we draw the velocity diagram first? But for drawing the velocity diagram, you should have the direction of two velocities now. But in this case, what is missing here? What is missing here? In this case, is it possible to us to draw the velocity v heli? Is it possible? In this scenario, we have only thing known to us. We have only direction of ship. Direction of heli is unknown to us now. So from this space diagram, why we have drawn space diagram here first? Because from this space diagram, we got the direction of relative path, and whatever the direction of relative path, that will be the direction of relative velocity. Okay. Means why we have drawn the space diagram first here? Because from this space diagram, what we got the direction of relative path. And from the relative path, we got the whatever the direction of relative path, same must be direction of relative velocity. And then guys, so here in this diagram, first of all, we have drawn V ship. Then from V ship, with respect to V ship, we have drawn relative velocity of heli with respect to ship. So we have shown the direction of V heli, relative velocity, and then we have drawn the V heli. Means first of all, we have drawn the V ship, then we have drawn relative velocity, because here we got the direction of relative velocity, and then at the end we have shown the direction of absolute velocities. Okay, are you getting my point? Try to understand the scenario here. Any doubt in this discussion, guys? See, if you are good with things, you can skip. See, it is not compulsory to draw this one. You can directly write down this statement and everything. But showing all these things now, guys, gives you a good impression. Some things then, okay, means drawing space diagram, drawing velocity vector diagram, means you can directly show, guys. It is easy to understand. If it is helicopter in south direction, if if helicopter wants to meet the ship, then it must go in north direction. That is a common sense, guys. Okay. But showing all these things, it gives a good impression. Oh, this guy studied properly. He knows everything. Like that. And our target is what? We want to give just impression, guys. At the end, see, means if you have solved 3 questions properly now, guys, then automatically you will get a grade 3 or grade 2. Just you have to solve 3 questions correct way, and remaining 3 questions just hop. Automatically you will get a good impression to the examiner. Okay. And drawing such type of things will give you good examiners. Means sometimes now what will happen? There is a boundary, grade 6, grade 7. And such type of things will help you. Okay. Now before going further, guys, first of all draw this drawing. Show this one. Show these things, relative path, give the name of the drawing. Then write down these given things. V ship, we know the direction of ship. Then this one. Guys, see the path. First of all this drawing. Then these given things. Then this one. After that, write down this, give the heading of the A part. Then draw this. What is the name of this figure, guys? What is the name of this figure? Velocity vector diagram. Okay. Then draw the velocity vector diagram. After completing velocity vector diagram, then write down this one, this calculation. If you have space, you can write down beside the velocity vector diagram, no problem for me. But write down properly. After that, this final statement. Otherwise, this must be at the end, guys, after calculating theta. This final statement, this is what our answer of A part. Okay, guys, anyone have any doubt in this discussion? Okay, good. So please everyone complete these things. What is the target in B part, guys? What they are asking us, time taken by the helicopter to meet the ship. Okay, so how much time taken by the helicopter to meet the ship? Very simple part, guys, not that much difficult. Okay, so in B part our target is what? We have to find out time. What is our target? We have to find out time. Okay, try to see the scenario here. What we have to find out? We have to find out time. Okay, now here instead of here I will write down here. Okay, what we have to find out? We have to find out time. Okay, how to get the time? For that purpose, what we are going to do? First of all, we are going to calculate value of relative velocity here. For getting the time, what we are going to first of all calculate? Value of relative velocity. Now observe this, guys. Observe this drawing. Observe this drawing, everyone. Observe this drawing. So, what will be this complete angle, everyone? What will be this complete angle? What will be this complete angle, everyone? This black one. How to get this black angle, guys? This black angle. Okay, we will say this black angle as a what? Black one, this one. This one, we will say theta 1, guys. What we will say? We will say theta 1. Okay, so what will be the value of theta 1? This complete, guys, this complete angle. What will be that value? How to get that value? See, theta 1 plus this theta 1, complete angle, guys, theta 1 plus theta plus 60 will be equal to what? Theta 1, this theta and this 60 will be equal to what, everyone? Will be equal to what? 180 degree. So theta 1 will be equal to what? 180 minus 60 minus theta. So theta 1 will be equal to what? What will be the value of theta 1? Everyone, what will be the value of theta 1? Please do the calculation. So 180 minus 60 minus theta. How much value of theta we calculated? 180 means this will become 120 minus theta. How much theta we calculated, guys, earlier? 7.4638. Okay, so see the scenario here. So theta 1. So 120 minus 7.4638. How much? Theta 1 will be equal to what? 112.5362 degree. Okay, so we got what? We got theta 1. Now why we calculate theta 1? From theta 1 we will get directly relative velocity, guys. By sine rule, we will use sine rule. So by sine rule, try to see the scenario. Relative velocity by opposite to relative velocity. Opposite to relative velocity is what? Opposite to relative velocity, sine theta 1. Opposite, this one is relative velocity. Opposite is what? Sine theta 1. See the scenario here. Sine theta 1 is equal to what, guys? What we have? We have a V heli. Opposite to V heli, sine 60. So V heli divided by what? Sine 60. Try to see the scenario. So relative velocity will be equal to what? Relative velocity will be equal to what? V heli multiplied by what? Sine theta 1 divided by what? Sine 60. Okay, guys, are you getting my point? Try to see the scenario here. Okay, we are nearer to our answer. So relative velocity will be equal to what? Relative velocity will be, what is V heli value? V heli is what? 120 into what? Sine of what, guys? Sine of what? Sine of theta 1. Theta 1 is what? 112 0.5362 divided by what? Sine 60. So everyone, please tell me the value of relative velocity. Everyone, tell me the value of relative velocity. This is relative velocity, guys, with respect to ship. So 120 into what? 120 into what? Sine of 1 minute, guys, let me check. 5362 divided by what? Sine of 60. Okay, 127.983 unit. What will be the unit, guys, here? What will be the unit of relative velocity? Knots. Okay, so we got the relative velocity, and see, once we got relative velocity, for time what we need, guys? Distance. Which relative distance will be here, guys? What will be the relative distance traveled by the helicopter here? What will be the relative distance traveled by the helicopter? What will 300 nautical miles? See, this is what is meant by this 300? So what we can say here? Relative distance will be what? Relative distance will be what? 300. Okay, 300 nautical miles. Okay, guys, are you getting my point? So relative velocity will be equal to what? Relative distance. See, same scenario as we discussed, divided by time. So time will be equal to what? What will be the time? Relative distance divided by what? Relative velocity. So time will be equal to what? What will be the relative distance, everyone? What will be the relative distance? 300 not divided by what? 127.983. So please everyone do the calculation time. So 300 divided by 127.983. How much value, everyone, we are getting? 2.344 hour. Okay, it means what, guys? 2 hour. In minute, how much? If you multiply 0.344, if you multiply, guys, 0.344 by 6 multiplied by 60, 0.344 multiplied by 60, how much, guys? 20.64 minute. Okay, so in 2 hour 64 minute, helicopter meet the ship. Okay, guys, are you getting my point? Try to see the scenario. In how much time helicopter is going to meet? In 2 hour 20 minute. Okay, anyone have any doubt in this discussion? So guys, now what you have to do? How you have to write down? First of all, write down this one, guys. First of all, write down. Try to see the scenario here. First of all, write down this one up to relative velocity. Give the target time, relative velocity, and then this one. Okay, no drawing, guys. We have already we have drawn the drawing. So first of all, these things, and after that this one. Okay, everyone getting my point? Try to see the scenario here. Please complete these points.